we will now wait for questions. Yeah. Okay. Yeah. Today we will do the course introduction for signals and systems. And firstly, let's introduce myself. I think you two know me. Yeah. And yeah, I'm Xiaowei Chen. You can call me Dr. Chen, Xiaowei, or Wei. Yeah. And this is my phone number and my email. If you have any questions, problems, just email me or text me. Yeah, I will be there. Yeah, sometimes maybe I will not respond to you very quickly, but if I see your message, your email, I will respond it. Yeah, and this is our office hour, and we will have the office hour like Wednesday from 2 to 3:30, and Friday 9:30 to 11 like 30 a.m. And if you I know some of you are very busy, yeah, during the semester. Maybe you don't have time during this time. I can totally understand, and you can email me to schedule the meeting with me for a different time. Yeah, and yeah, we can try to find the time is valuable to you and also to me. Yeah, even it is on the weekend, that's fine. Yeah. Yeah, and I think it will not take too long for us. Yeah, and yeah, my office is like LS in LSC 160, and it's very near. Yeah, just maybe 20 meters from this classroom. Yeah, and yeah, I'm just talking about my information. Yeah, since you haven't taken my class, yeah, my name is Xiaowei Chen. Yeah, and you can call me Xiaowei, Dr. Chen Wei. Yeah, and this is my phone number and email. You can text me and email to me anytime. Yeah, and this is the office hour and Wednesday, Friday. And you can schedule the appointment for different time with me. Yeah, sometimes I know, sometimes you are very busy. Yeah, and this is my office, LSC 160, and this is the Zoom. Oh, when we have the office hour, I will I also have the Zoom office hour. And if you log in the Zoom and found I'm not there, maybe sometimes I forgot to open my Zoom. So, but you after you log in, I will have the email and I will log in too. Yeah. If you have any questions about me and about office hour thing, and just let me know. Okay. Oh, one more thing. For this office hour, it is not fixed for now, and I need you three send me your schedule next semester, and I will adjust this office hour according to your schedule. Yeah, and also yeah, let's talk about this class goals. Yeah, firstly we will introduce general information about this course. This is today's goals, and firstly we will introduce general information about this course. And then we will try to get ready for the coming challenges this semester. I will talk about what we will learn in this semester and what you will do in this semester. Yeah, and lastly, we will summarize this course into 5 basic questions. Okay, and this is today's goals. Any questions so far? Okay, and yeah, this is a textbook. I don't know if you check the syllabus, I sent it in the Blackboard. Yeah, this is textbook, and we will have the homework, and all the homework you can find in this textbook. And actually, you can find the PDF version, maybe online. Yeah, I don't know if you search it, but you can find it. Yeah, so if you don't want to buy it, yeah, yeah, but I cannot. Yeah. And okay, this is our course expectation. Yeah, in order to succeed in this course, firstly, you need to attend the class in person, and this is mandatory and will be recorded. And this is mandatory. This class is not like the microcontroller. It's not like the microelectronics. This class is doesn't have many labs. Lots of theory thing. So if you miss one class, maybe you will don't understand the next. So that's the reason why I have these requirements. Yeah, attending the class in person is mandatory. Yeah, and then I have the office hour. If you have any questions, problems, just come to me, and we will talk about that. And doing homework independently and promotely. And we will talk about that later. And the homework will come from that textbook, and all the exams are from those homeworks. And maybe some numbers changed, but all the similar microelectronics. Yeah. But if you do the homework independently and promotely, and you will have a great grade for the exams. Okay. Yeah. So when you prepare the course and the hand-ons, textbook and homework is are very important for you. And then this is attendance policy. And in-person class attendance is mandatory and will be recorded. But all students need to send the attendance sheet during each class. Since we have only 3, I will send it for you. Yeah. And I know sometimes you have some emergency and some students will have some feel uncomfortable. So every time I will have the Zoom. Yeah, at the same time I will open the Zoom, and you can online attend this class, but only due to health related issue or special reasons beyond control. Yeah, you cannot oh, I don't want to have today's class. Can I have this class online? No. You need to give me the reasonable the reasons I can accept. Yeah, and because because in person and the online it's different. Yeah, sometimes I don't know if you understand it really. If I didn't, I cannot see your face. Yeah. So I suggest every student just attend the class in person. And every class I will record it and I will upload the video in the Blackboard, and you can check it in the Blackboard. And if you attend the online attendance, have the online class, and also you need to submit a report. Yeah, give me within 24 hours. Yeah, and if you cannot attend the online class, and you can watch the offline video. Yeah, we will record the video every time, every class, and you can watch the offline video. But you need to submit a report within 24 hours. Yeah, and doesn't any questions so far? Okay, and then both online and offline attendance require pre-approval from me, and you need to email me or text me at advance. You cannot we have already finished this class. You text me or email me. Oh, I cannot. Sorry, I forgot this class today, and I will not accept that. Yeah, all classes will be recorded, and the lecture videos will be made available online in Blackboard for review or makeup attendance. Yeah, this is attendance policy. Any questions? Okay, and then this is grading policy. And actually, our grading policy is not complicated compared with the microelectronics. Yeah, and we have 4 middle exams, and those middle exams will last 40 minutes, and from the highest to the lowest will account for 50%, 30%, 12, 30%, 10%, and towards a final grade, totally 50%. Any question about this? Yeah, which means you have we have 4 midterms, and I will give for example, we have A, B, C, D, and if Honey had the highest grade for the C exam C, and C will have a grade take up 50%. That makes sense to you? Yeah. Okay. And then 1 2-hour final comprehensive exam we will take 20%. Yeah, we will have the final exam, and this final exam will last 2 hours, and it will take the 20% like a final grade, and the homework assignment will have 20, another 20, and the class attendance will account for 10%. Yeah, any questions so far? And the letter grade is based on this. I think you are familiar with this. And I will do a round for the final grade like that. And actually, there is a good news. This is just the chat. Yeah, there is a good news. The final exam can be waived, but there is a condition. Based on all midterms and homework assignments, students with a current course average above 90% may be eligible for a final exam waiver, which means if you have 90% for the 4 midterms and the homework, which means you have already totally understand what you have learned, and yeah, you have already totally mastered what I have given to you. So you will I will waive your final exam, and your final exam will be now count for the maybe just 100 yeah. Okay, so happy, am I right? Yeah, but however, there are some other conditions. You need to take all 4 midterms. Yeah, and you cannot miss more than 2 classes without appropriate justification. Yeah, you can ask me advance for some if you feel uncomfortable, if you have an emergency, but I will not count that as a miss. But you can sometimes maybe you have some very interesting, you miss no more than 2, it can be accepted. But yeah, that makes sense to you? Okay, and you must submit all homework assignment on time, no late submissions. Yeah, that makes sense to you? Okay, yeah, this is a good news for you. Okay, yeah, this is the course, this lecture's information so far. And have any questions? Okay, and let's talk about the signals and the systems. Actually, this is a fundamental course. Yeah, and we know some course is about the technologies and applications. There is an example, yeah, like a microelectronics, microcontroller. You can see when we talk about microelectronics, microcontrollers, we just use some theory, some companies to build some applications. Yeah, you just try to construct some robot and yeah, including robotic robot. Yeah, this is a technology and application. But the systems and signal and system does not belong to this part. It belongs to, yeah. You can see before we talk about what it belongs to, what is signals and what is systems? What is system? What is signal? Have you ever think that before? Yeah.
That's all I know.
Your phone?
Yeah.
Your phone is a signal?
When you when you text something, you send it the signal is sent.
Oh yeah, that's true. That's true. Yeah, actually, have you ever? Let me ask you the other question. Yeah, that's good. Yeah, that's good. Yeah, let me ask you the other questions. Firstly, what's the difference between signals and a system? Have you ever think this before?
Systems take the signals and make them worth something.
Yeah, that's right. That's right, very right. The system is just take some signals and output something. Am I right? Yeah, this is a very good example. The phone actually it's a system. Am I right? This phone receives some signals and output some signals. That makes sense to you. It just receive some video, audio signals and display it on the screen. Am I right? Yeah. So the phone is a system. Yeah. The system, the signals is just what is signals? Yeah. Like a radio wave thing. Yeah. And the signals is just the quantities carry out some information. That makes sense to you? Yeah, this is the signals. Yeah, like we see, the brain this is just if we want to deal with this thing, it's some signals. Yeah, we can brain signals thing and like the radio wave thing. Yeah, this is the signals. And we talk about our voice, our sound, audio, video. It's just a signal. Am I right? That makes sense to you? Yeah, and some like robotic. Yeah, some robotic. This is robotic thing. It's kind of a system. Yeah, because it will when you do you like I know like for the robotic class you finish some small robot and it can work very long distance. Yeah, actually you can see it's a system. Yeah, you take some signals, you give it some like a system and signals, and the robot will deal with this signal and output and give a signal to the wheel and tell the wheel how long you can work, how when you will like turn like that. Yeah, that makes sense to you. Yeah, and actually systems and signals is a fundamental theory, and it is based on mathematics, physics, chemistry. Yeah, and you can see the signals and the system. Like we talk about, the phone is a system. Am I right? And the like video, audio is a signals. Am I right? These signals will your phone will receive these signals. Am I right? But have you ever think about if we want to deal with this signal, how can we do that? If we want to deal with this brain signals, audio video signals, and the robotic signals, other signals, how can we do that? You don't know, am I right? Yeah, this is what we will learn in this class. How can we try to abstract, represent this thing in a mathematical form, in some like a form we can understand? That makes sense to you?
I saw a bunch of TikToks about how it's a lot of Fourier transforms and boss
Yeah.
stuff.
Yeah, this is like a if you know like we have already talked about in microelectronics. Yeah, actually it is like how can we deal with signals? Yeah, if we want to analyze signals, we try to transfer it from the time domain to the frequency domain. Yeah, and then it will help us to try to like deal with these signals. Yeah, this is just like what we talk about in this class. How can we like try to represent the every quantities like in the real world, in the mathematical form, we can understand, we can analyze. That makes sense to you? Yeah. And how can we represent a system? Yeah. To like make these signals after go through these systems and then get what we want. Yeah. For example, robotic. How can we like design this robot and I input some like angle system and the speed system, speed signals, and how can the robot like just run it in a street and turn some angles in some angles? Yeah, this is what exactly system and the system signals and system will learn. Yeah, you can see when you like do some labs in the microelectronics, in the robotics, sometimes you just know, oh, I just need to input some variables and let the robotic do something and like achieve something. But sometimes you don't understand the theory behind that. Yeah, this class is just help you to understand all the systems, all the signals. Yeah, that makes sense to you? Yeah, this is just this class. Yeah. And then let's talk about the signals, the systems and the signals. You can see, usually the signals is just the input and the output is the signals. Yeah, like there is a system. Yeah, this system receives some input signals and then deal with these signals and output some signals. Yeah, that makes sense to you, like the phone. Yeah, those phone and just like for example, take the picture. This picture is just like a image signal, am I right? And then after you get the camera process, and then it will display this image in your phone. It's just kind of output. Yeah. So this is difference between the signals and the system. And the signals is just the input information, output information. The system is just the process, like the some rules, some process, like I deal with these signals. Yeah, actually, it's easy. It's not difficult to understand, but the difficult part is how can you represent this input? How can you present this output? How can you present this system? Yeah, so this is what this class will learn. Okay. And before we talk about the signals and systems, and let's talk about some applications. Yeah, some applications you will be very familiar. And the bioenergy. Yeah, I don't. I think you all have already saw something about the bioenergy and communication and law enforcement and defense applications. Yeah. Not only those four, like many applications, you will see the something like based on the signals and the systems. Yeah, for example, the bioengineering. Yeah, you can see this is a vital sign monitoring. Am I right? Yeah. So if like in China, like we have a doctor. Yeah, but this doctor, they don't like the doctor in American. They just like look your face and look your maybe your tongue and tell you you have some illness and you need to take some like medicine. But in American, in Europe, and sometimes if like usually doctor need to if doctor need to tell you what illness you have, they need to have some proofs. Yeah, like proof, and they need to take CT. They need to heard your heartbeat signals. Yeah. So, but how can you get this? Yeah, this like a CT and CT signals and this heartbeat signals, blood pressures. Yeah, this those, what are those? Like if you haven't heard signals, what are those? Like the heart rate, like blood pressure, like the virus pressure, and like some oxygen, blah 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 blah. Yeah, what are those? Yeah, you know. Actually, if you give those things a common name, what you will give? Yeah, for example, if you want to the phone, the sound volume, the video speed, what you will give it? Yeah, like a general name.
Application.
Application. Yeah, that's a good thing. Yeah, that's a good thing. Yeah, actually, the applications is just like it's some something I can use like that. Yeah, but those things, if you know, it's just information. Am I right? Those are all information. Am I right? The information, it can stand everything. Am I right? Yeah. So the signals is just information, but it's just like I said, the signals is quantities carry of some informations. Yeah. So those are all informations. Like signals is just we want to find some form to represent this information, the heart rate, the blood pressure, and those things. And those things it's just like the signals, and these signals is just like try to represent this information. That makes sense to you? Yeah, this is a very typical signals exam. And this one is a robotic prosthetic. Yeah. And I will show you a video.
Hi.
Wait me for a moment. Okay. I don't know if you can hear this thing.
I'm Nigel.
Wait for a moment.
I lost part of my arm in an accident at work a few years ago. Since then, I've been fortunate enough to be given one of these to trial. This is the Be Bionic V3. It's a prosthetic hand, and it works from sensors on the inside and outside of my arms and muscle control.
No.
If I activate this sensor, the hand opens. Activate this one, the hand closes. It's got 8 preset patterns, which I can use throughout the day. I can move the thumb. To give me point grips. This I can use, I can tie it. And it has a wrist on it. And this is all controlled purely by 2 muscles, one on the outside and one on the inside of the arm. As you can see, it's a really nice piece of equipment. And I love it. This is the Be Bionic V3. This is key grip. This allows you to hold credit cards, bank cards, car keys, etc, etc. I now move to a point. Pretty self-explanatory. This one will allow me to type on the keyboards. We then move the thumb to this position and we can get a tripod grip. So picking small things up. We can then change the grip again. And this is power grip, this is for heavy things, this is for shaking hands, this is for being human. Then we have this grip here. This is one that scares children and upsets my wife. Rotate the hand here. This is trigger grip, but it can be adapted if you so wish, if you've got the guts. We have a relaxed grip. This is so that when you walk down the street, it just looks like a normal hand. You can close it a bit further if you want to. And then we have a mouse grip. This will hold a mouse, single click, double click. And they're developing this now so that you'll be able to, soon you'll be able to drag and drop.
Yeah, actually, this video is not very new. Yeah, actually, for now, it is much like advanced.
Hi, I'm Alistair Gibson. I am a prosthetist orthotist here at Sky. I'm also a clinical
Yeah. This is a question I want to ask you. In this like video, what it includes, what signals it includes, and what system it includes? Yeah. Let me listen.
Hi, I'm Nigel. I can move the thumb.
Yeah, you can see. Yeah. Actually, yeah, you can see. Firstly, yeah, this person want to control this one. And like the brain system, neural signals will try to go through this robotic arm, am I right? Which means this robotic arm is like a system, and it will get the like neural signals, like the brain signals, and then deal with inside the arm, and then produce some like electronic signals and the motion signals, and control the hands and the fingers, which means the brain signal is just an input, and this is a system, and then process it and then output it. Yeah, that makes sense to you. Yeah. So let me try to go back. Yeah, this is a very like a bio engineering, like signals applications. Yeah, actually there are many like similar applications so far. Yeah, And also the communication, yeah, this one is like easy to understand. Like this is the phone, yeah, and the speaker thing, and you can see the in these applications, what are the signals? What are the system?
The systems of,
Yeah.
TVs, the
Yeah.
towers, and
Yeah.
the signals are just what they send back.
Yeah. So like the system and systems, you need to like tell what is systems, what is systems. So, yeah, it's very important. Yeah, and also the law enforcement. Yeah, yeah. Actually, I think this one is a very like yeah. I think you have heard this before, am I right? Law enforcement. Yeah, this one is just a funny like image because this old lady doesn't want the like cars like pass by their house, so they just hold a hair dryer to like consider it is like a speed measurement. Yeah. So this is just a fun image. But do you know how the like law like this speed measurement like do using this equipment? Yeah. Do you know how it will?
Like the actual school, I don't wanna say good, I don't think it's good, it's a little sensor thing, like
Yeah.
you put it in the vehicle, it'll tell you back how fast. That's what I assume happened.
Yeah, you're right. Let me ask you, firstly, what is Doppler effect? Do you know?
The noise we hear.
Yeah.
Further away, less frequency of noise.
Yeah. That's right. Which means like between the observer and the like the cars and if there is a motion like there is a relative motion and it will have the specific frequency change like that. Yeah, which means if you use this equipment, you can like emit specific frequency signals. And if these frequency signals like meet the car, and the frequency will change, and then return to the equipment. And after this equipment like get that, and it can calculate the speed. Yeah. So this is just like this equipment, something like what? Yeah, it's a system of signals. Yeah, it's a system. Like it will emit some signals. Like am I right? And these signals, like after he met after these signals met the cars, it will like return. And then this equipment get that and produce it and then calculate the speed. Yeah. And this is the other example. And then defense applications radar. Yeah, I think this one is also very easy to understand. This radar detection and region can determine the range, angle, or velocity of objects using the same like a thing. Yeah. Okay. And then, yeah, also like this is the other defense applications. The sonar, the sound navigation and region is useful for exploring and mapping the ocean because sound waves travel further in the water than do radar and light waves. Actually, they have different two different like style, but those two style can all like both detect the objects and can measurement the speed, the angle, the location thing. Yeah, but this are all like this is just like the signal, and those part is just a system. It will like receive, produce, and output something. Yeah, that makes sense to you. Okay, now you can tell what's the difference between the systems and the signals. Yeah, so like let's talk about in this class. We will focus on 5 basic questions. The first one is how to represent a signal mathematically. Yeah, because we want to why we want to represent a signal mathematically? Why? Yeah, for example, like this. So when I talk about that, when I talk about like when I give you this class, I record it, and the sound is just like the video audio is just a signal. But these signals, like I just like upload in the Blackboard. Why we want to represent in a mathematic form? It seems like a useless for us, and why? Huh? What?
Understand the signal.
Yeah, but why we want to understand the signals? Actually, you can see, you need to you take the robotic last semester, am I right? Yeah, you like have the project, the robotic make the small car go go direction, and but the Dr. Zhang asked you to improve it. How? How can you improve this one? How can you improve the system? How?
To like measure it, you can like put the formula in there, and you feel like make it more efficient.
Yeah, like Honey is very right. If you want to improve the whole system, you need to try to write it in a mathematical form. Am I right? For example, this robotic car like has when it goes straight, but it doesn't go straight. There are some like noise sometimes. If you want to like remove this noise, which means you need to analyze the input. Am I right? The input signals. You want to remove this noise. Am I right? Yeah. So like we can formulate and solve our problems analytically. Yeah. Like I ask you, how can you improve your robotic car? Yeah. If you cannot represent these signals, this is mathematically, you don't have a clue to improve it, am I right? But if you can represent a signal, you can represent your input like in a mathematical form. You can try to resolve your problem analytically. After you represent your signals, you will say, if I want to improve it, what I should do. If I want to remove the noise, what I should do. Am I right? Maybe I need to add a band filter and a pass filter, like low pass filter. Yeah. This is just like the purpose, why you want to represent a signal mathematically. Okay. And how to acquire a signals in a discrete time form. You can see, for most signals in the real world, almost every signals, it is just continuous time form. Yeah, you can see the sound signals. You can see if you the audio video, it like the electrical thing. Actually, the real world signals mostly are the continuous time, but the continuous time form, yeah, we cannot represent signals in a continuous time. Because why? Because if you represent signals in a continuous time, which means you need much energy, you need much things. Yeah, you need many things to represent it, to storage it, and to process it. So that's the reason why we want to acquire signals in a discrete time form. So we can operate on a signal digitally via a computer. Yeah, like we talk about in microelectronics. Why we want to transfer the signal from the analog to the digital? Because we can use the code I gave it to you. Am I right? You can easily to use the function to do the Fourier transform, and then you can easily get the result. Yeah. Okay. And then how to analyze the signal numerically and systematically. Yeah, this is why we that so that we can interpret the content of the signal. Yeah, if after we analyze the signal numerically and systematically, we can easily to interpret the content of a signal. Yeah, this is what we will learn. Also, we will learn how to process a signal computationally and functionally, so we can manipulate a signal purposely via a system. Yeah, we can try to change this system. We'll try to remove the noise and how to transmit multiple signals via a channel wirelessly and jointly. Yeah, this is communication. Yeah, in robotic, I don't know if you need to communicate with other, maybe your like a phone. If you click no, yeah, for now I think you don't need that. But sometimes if you want to communicate your like phone with your computer, your computer is communication. The signals will be transferred, will be communication. Yeah, this is what we will learn in this class. We will try to represent a signal, acquire a signal, analyze a signal, process a signal, and transmit signals. Yeah, this is what we will learn in this class. Any questions so far? Okay. Let me. We have time. So, and then, yeah, this is our course roadmap, and we will have 3 sections. The sections 1 will is signals and systems. And the chapter 1 is signals and systems, which means we will learn how to represent signals and how to represent systems and some properties for signals and systems. After the chapter 1, we will have the midterm 1. And then chapter 2, LTI systems. Do you know what is LTI system? Linear time invariant, like the system is linear, is not non-linear, and the time invariant, which means the system will not change according to the time, which means this system is like this at this moment, and after 1 hour, and the system is still that thing. Yeah, this is our IT system, and after the chapter 2, we will have the midterm 2 and chapter 3 and Fourier series. And what is Fourier series? After you take the microelectronics.
Oh, is it like the zero, like formulas you would make for the time?
Yeah, use a formula to transfer the signals in time domain to frequency domain. Yeah, we will learn it yeah. And but do you know what's the difference between the Fourier series and the Fourier transform? Yeah, the Fourier series is specific for period signals, and the Fourier transform is for the non-period signals. Yeah, so after Fourier series, we will have the midterm 3 and chapter 4 Fourier transforms and sampling theory, and after 4 and 6, and we will have midterm 4, and the communication is just something you may want to know, yeah, and but there is no homework exams for the communication, yeah, and yeah, this is the whole course in this semester. And any questions so far? Okay, yeah, this is this class will be interesting. Yeah, but not very easy, but if you follow me, and you will survive, and yeah. And try to, yeah, we don't have labs. We only have the homeworks and the exams. If you finish the homework and very well, and you can get a very good grade for the exams, and then you may have the final exam waiver. Yeah. Okay, any questions so far? Okay, yeah. Okay, this is today's class, and we will have the formal class next Monday. Yeah. Okay. Yeah, and ODE. Yeah, we need that. Yeah, but don't worry. Yeah, like a question. Yeah. Do you have the ODE this semester? ODE you have AutoCAD. Oh, that's great. That's great. Yeah, because this class will, yeah, need that one. Yeah.
Yeah.
Okay, see you next week.